I hope you're having a good time. I hope that yesterday you were able to um, work well with determining the equation of graphs, of functions given the graph. Again, just a reminder, send me an email if you have any questions. Now, you know that I love mistakes, right? I love mistakes because we can learn from them, right? But sometimes we make a mistake that we didn't want to make. Okay. So the question that I have for you is, what do you do when you make a mistake typing? What do you do? That's right. We use the good old undo button or Control Z, right? Wouldn't it be great if we could just press that button anytime we make a mistake in life? At last, it's finished. My universal undo button. All that's left to do is test it. It works. Wait a second. And the machine is uninvented. Control Z, Control Z, Control Z. I feel like we can all relate to this as a metaphor. All right, so just a little smile for you. Let's get back to the lesson. Okay, please make sure you have someone to talk to. If you're sitting alone, please turn to the group behind you, in front of you, to move um, to another seat. Actually, I'm going to switch that up. I'm going to ask that Miss Copland pause in a second. I want you guys to go to the whiteboards and get my markers. You know where they are, or Marley, you can help get them. So get markers, get chalk, and then start this video again when you are ready to go. All right. So we're going to look back at the input-output machine. Remember, the X goes into the machine. The machine does something like a rule, which we realized, oh, that's just a function. And out comes the Y. Okay, so you put an X in, do some kind of equation, and out comes a value for the Y. And this is the input-output, or also known as the function machine. So let's return to the game. What's the rule? But now there is a twist. Woo-hoo. Okay, so let's just go back to this slide. What is the rule? Prove it. So I don't need you to prove it, but I want you to find the rule and write it down, i.e., write down the function. Okay, so I want it to look like x equals or 4 equals, sorry, write down the equation. Okay, so it would be something like 16 equals, and what did you do to the 4? And then 19 equals, and what did you do to the 7? Okay, and so Ms. Copland, anytime I say pause, you can pause, give them some time to work. So this is a good time to pause. Okay, so now what I want you to do, this is the twist. Can you think of the rule to get from the output to the input? So imagine I only gave you the 16. I gave you these numbers, but now I'm saying, instead of what did we do to the 4, right? What did we do to the 7? Now what I want us to think about is, if I give you the 16 and 19, what can you do to it to get the 4 and the 7? Okay, take a pause and figure that out. All right, so now the question is, how are these two rules related? Okay, look at the two rules, see if you can find any connection. Pause. Okay, so here's another one. What is the rule to get the output given the input and get the input given the output? So basically, I want you to write the rule again for this machine, for this function machine, but write it so that it goes in the ways of the arrow, and then otherwise do it the reverse way. So like, what if I take the 27, what do I have to do to it to get a 3? Okay, so write both of these down on your whiteboard and look at how they are connected, if they are. Pause. Okay, what if the rule you were using is y equals 2x minus 1. So if that's the rule, what is the rule that you use if you are given the output and need to find the input? Okay, so you can't use this function is not going to work for you because I give you the y value, and how will you find the x value? So I want you to find a rule that is related to this one but allows you to find x. Pause. So is this where you got to? Right? Where we saw, oh, well, we first would have to bring the 1 over, right? We would first have to add a 1 to the y and then divide everything by 2. Now, if you are coming up with these rules and you're struggling, well, go back to the scenarios where you have numbers to test out. Use actual numbers to test if this rule truly is the opposite direction. Okay? Now, let me tell you something. What you have just created, this rule, also known as a function, is actually called the inverse function, right? So the inverse is like doing the undo, okay? And so when we take a function and figure out how to write it backwards, for lack of a better term, we are actually writing the inverse function. So let's have you practice. What is the inverse function of y equals x squared? Okay, so in order to have the inverse, you need to be solving for x. So x has to be isolated. Pause. Okay, did you get that the inverse function is the square root of y? Right? And really, it's like, oh yeah, the opposite operation of squaring is square rooting. Let's try this again. What is the inverse function of? So if I give you a function of y equals x squared plus 1, go ahead and find the inverse function. Pause. Okay, and did you get as the inverse x equals the square root of y minus 1? So keep in mind that the square root is of the entire y minus 1, of the entire binomial, because the first thing we do is we're going to subtract 1 from y. So if we go back to that function machine, the one that we have on the left is the original function machine, right? So we drop a diamond in there and it shoots out a circle. Well, if I take the inverse function machine, what I'm actually doing is I'm putting a circle in, a sphere in, and it spits out this diamond, three-dimensional diamond for me. Okay, so whatever originally came out, like the sphere, well, now we're taking that output and we're putting it in so that we can get the original input. Okay? Sometimes we just need to do that. Okay, let's remind ourselves. What is the inverse operation of addition? Say it out loud. You got it. Subtraction. What is the inverse operation of division? Say it out loud. I don't hear you. Say it out loud. That's better. Multiplication. And lastly, what is the inverse operation of squaring something? You got it. Square rooting something. There's my grammar. Okay. And so this is why I was talking about the undo button or the Control Z button, right? Because what we're doing essentially for the inverse function is we're undoing what the function did. All right, that's my last slide. Grab a seat and we'll continue on with the lesson. Okay, please turn to your booklet, page 60.